Hi folks, welcome to The Breaky. My name's Henry, and today we are going to solve a frustration that I have with my particular setup, or at least we're going to get closer to solving a frustration. So my setup is such that in order for me to play with a CoCo in front of me, I have to remove the keyboard. I've got a very small amount of space actually in front of me. So I kind of have to move a lot of things, bring a CoCo over, plug it in, everything like that. You know, it would just be so much easier because I can string video cables off wherever. I've got a TV that will let me input the RF from from the machine, and then it outputs, it rebroadcasts a composite signal. So I can run that composite video and audio over to a capture device right in front of me. But what I don't have right in front of me is the keyboard. Yeah, I mean, usually the joystick cables are long enough, but the keyboard I don't have because the keyboard's on the computer. And the computer's over there. So the solution to that is going to be to replace the CoCo's keyboard with a USB keyboard. Theoretically, this should be relatively easy to do because we have this wonderful world of a $4 part called the Pi Pico, or the Raspberry Pi Pico, and the Raspberry Pi Pico has a software development kit in it that has something called Tiny USB, which can act as a host so I can plug a keyboard into it. I'm already looking at a certain measure of frustration because I haven't really looked at this SDK yet. And I've looked a little bit at the documentation and I can't really find much. So getting it going is probably going to be a little bit of an exercise in frustration, but I have high hopes because it should be a simple matter to take what's coming in from once I get things in from the USB port into the Pico, I should be able to readily translate that into matrix operations. And there's a wonderful chip that's been used in other projects called the MT8808 that acts like an array of switches. A matrix array of switches. So I can tell the Pico to take the thing from the USB keyboard, turn it into a matrix array information to put onto the matrix array of switches, run that matrix array of switches into the CoCo where the matrix array of switches that's physical switches normally goes, and then I should have a USB keyboard. And then I can take a USB keyboard extension, plug it in over there. Yeah! So today, we're going to see how that goes. Right here on the Breaky. So the first thing that needs to be done is to get the development environment set up. And I'm going to start by actually creating a Git repository for this. Figure out how to get the Raspberry Pi Pico C++ stuff. I have used the Pico before. However, I've only used it with MicroPython. I don't want to use MicroPython this time. I want to use I would prefer to use assembly, but this actually isn't ARM Cortex M0, so we'll go ahead and use C. Why not? It's what they show us with. And we've got the getting started. So the first thing I want to do, I think I've got a lot of this already done. The intro, blah, blah, blah. I've got a micro USB cable. Let's see. Let me make sure that I've got my micro USB cable. And yes, I do. My trusty micro USB cable is right here, and I do believe it is actually plugged in to the unit. So if I recall correctly, I need to hit boot cell and plug this in. Okay, yeah. So there it is. It's working fine. So that's open, that's great. Now this bit right over here, the debug probe, that doesn't happen just yet. I've already got Visual Studio Code installed. Install the Raspberry Pi VS Code extension. I do have Python, I do have Git, I do have tar, a native C and C++ and such, I do believe. Yep, I've already got those installed on the machine. macOS is not worried about, and install the extension. Let me see if I've actually got that installed. So if I go to my extensions, let's try Pico. Okay, Raspberry Pi Pico, and it is installed. So I've already got that. Nice. So let's see what we've got here. In the VS Code left sidebar, select the Raspberry Pi Pico object icon. Okay. So I'm looking for the left sidebar, which is over here. Ah, there we go. That's what I was hunting for. And I want to create a new project. Actually, let's do a new project from example. We'll select the example. Let's see what it's got from the name field. Select the blank example. And it says to VS Code subfolder, select folder, create. All right. First project, we take 5 minutes to install the toolchain, which apparently I've already got the toolchain going. So that I can quit. Oops, no, I didn't want to do that. All right, there we go. So with that, okay, that's good. Because it's okay. Open the left Explorer sideboard. You should now see blink.c. See the example code. All right, so we've got the example code here. Hard assert RC equal Pico okay, Pico okay. Am I going to keep saying Pico or Pico? I got to pick one. I really got to pick one. That's right down here. So I'll hit compile. So that should have created a target UF2. So what I should be able to do, and it should be this simple. And I have a blinking LED. It is that simple. Let me see what it says about using the UART. By default, we'll use pin 1 and pin 2 for receiving input. GP0 and GP1, so it's by default using those as TX and RX. So, what should be happening is serial UART console, input and output are sent over the UART pins on the device. By default, we'll use pin 1 for sending output and pin 2 for receiving input. You will need to connect the UART pins on the Pico series device to a UART to USB computer converter. So we're looking at pins 1 and 2, so that's going to be over here. That should work. Okay, so let's try that. Named, we'll keep the name. Console, hello world. Okay, and that's going to be on a Pico. That's fine. Version 2 is fine. Let's pull in UART console over UART and use project name as entry point file name, and we'll create. What I should have, let me make sure that TB210X, that's a TTY USB 0. Good. So if I compile, good. Let's do a boot cell and load. Okay, so that's fine. Let's go to the serial monitor and yep, that's fine. Text and start monitoring. Let's see if it works. Not very happy. I think I've got a misconfiguration happening here. Oh, there's one of my problems. I need to be connected to TTY USB 0. There we are. Ah! That's so much better. Now I actually see what's going on. Okay, that's working now. That makes me happy. I had no idea how just, oh my gosh, insane the build structure and project structure and everything else like that to get USB host adapter working on the Pico was going to be. And now the library that Pico SDK uses is Tiny USB. It does exist in the SDK. The question is, how do you get it to work in the SDK? What do you need in order to make it work? And where's all the documentation? Well, the answer to question number 3 is, it either is scattered across the internet or does not exist. But the rest of it took some serious digging, because this did nothing for me as far as getting it working actually in the VS Code environment with the Pico SDK plugin. So there we go. Tiny USB is not visible in the VS Code workspace. I looked at this one to see what's going on. And anyways, this is explained in the Pico examples README. Well, let's look at the Pico examples README and see what it says about that. All right, tiny USB examples can be come directly from the tiny USB examples directory here, which is the tiny USB examples in tiny USB itself, but those don't compile in the SDK. Okay, those that are supported RP20 devices are automatically included as part of the Pico examples build as targets name tiny USB example, whatever the heck. Okay, so they're the Pico examples build. Here's the fun part. Pico examples is not part of the Pico SDK. You have to get it yourself. All right, so I'm going to take this right here. I'm going to move down here, and I'm going to go ahead and grab that repository. All right, lovely. Great. All right, so now I've got examples. Now I've got USB stuff. And cmake list.txt. Now I can go over to devices and actually to host. And host to CDC MSC hit. I've got a host example. Lovely. I've got this example. And if this is doing what it's supposed to doing, I'm not sure if this will compile by and of itself, because I'm not sure that it knows where the Pico SDK is. But I can start a project that does know where the Pico SDK is, and I discovered that this actually does work with the Pico SDK. It's the way the Pico SDK likes to do things. All right. So the first thing I'm going to do is I'm going to open this directory in its own place. We're going to look at a few things to see what's going on with how this is working. All right, so we've got a few extra things that it's pulling in. String, standard.io, string.a, or standard.lib, standard.io, string.h. Okay, great. And it's got a couple of includes that we didn't have before. Board.api, tusp.h. Great. And it's also got tusp.config.c. There's a few other things in here, hit app, cdc app.c. But the tusp.config.h, from what I understand, is an important one to actually have in your project. So let's go ahead and try this. I will warn you, most of what I am going to do is going to be simple copy and paste. There's not going to be much else going on. The first thing I want to do is, let's see if I can't get an LED blinky, just the LED blinky working. Because in this one, it's not printing anything immediately as far as a heart, showing that it has a heartbeat. It's using the LED blinking task, and it's doing that kind of as its own thing. Okay, so we're going to try that. make sure it does not like it. Why doesn't it like it? Ah, I know why it doesn't like it, because I'm missing some necessary header files. Yeah, it's not compiling. No such file or directory, because it doesn't know where the heck to look. And this was the other problem I ran into. Where do I tell this thing to look for the things that it needs to find? Okay, so make this go away, bring this back over here. Remember our Pico examples? Well, that's where we are right now. We're in the Pico examples. We're looking at the host CDC MSC HID. And now I want to look at CMake list. This was designed to work with the Pico SDK and to run everything. Okay, great. Target sources. Fine. Everything's good there. Target sources understood. Target include directories. That's fine. Target link libraries. Look at this. Add dependency on Tiny USB host for Tiny USB device support and Tiny USB port for the additional board support library needed by the example. Okay, well, it's host support, not device support, but I need these two items right here. And I need them in target link libraries. So if I open cmakelist.txt and go to my target link libraries, that should fix it, right? 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 Let's find out. Target include directories, test me test, private, CMake list current dir, and CMake blah, 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 blah. Let's see if loading the libraries in actually makes this work. Do I need to include anything else? It didn't look like it, because over here, this was just hit public and CMake current list here, and it seemed to take care of it all by itself. Yay, incantations. I can't stand incantations. Okay. So let's come back over here and let's go ahead, save everything out, make sure these are both saved. It looks like it. And let's run a compile. It's still not happy. Ah, because we're missing a testmeconfig.h. That's another piece of the puzzle. We need to actually have something to configure Tiny USB to work. So rather than try and figure out what's going on, because again, it's a absolute quagmire, I'm just going to take what we've got over here. Let's see, can I copy the entire file? I can copy the entire file. And let's see if I can paste it. I can, that's nice. That makes me happy. And then let's go ahead and switch the language mode on this, because it doesn't seem to understand that .h is C. Okay. Somehow I got to go fix that. And again, whole bunch of incantation in here. Where the heck does TUSP MCU come from? I don't know. That, well, at least we're defining it. That, we're defining it. And that makes sense what it is. Mem section? Align? Well, we're aligning on 4-byte boundaries. That makes sense because we're a 32-bit system. All this stuff, I'm not sure what the heck goes on with that. I'm not sure what this means. These, at least, I can kind of get. Enumeration, buffer size, what we're doing as far as number of supported hubs, blah, 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 blah. Okay. This, at least, I can kind of parse. CDC ACM, which I don't know what the CDC is. I don't think I need it. The FTDI, I'm pretty sure I don't need that. These are all like serial things. I don't think I need those. The HIDs, I know what the HID is. I can use that. MSC, I'm not entirely sure what MSC is, but CUH2H device max, and it's allowing 3 interfaces per device. Okay, great. Lovely. And so some of this I can parse. Some of this I don't know what's going on. Okay. Now, if that's done, maybe if I run a compile now, and it compiles, and everything seems to be going fine. Okay, now, next test. Will the LED actually blink? Nope, that's not what I need. Actually, I can go ahead and pop you here. Will the LED actually... No, you're not the one I want. Here we go, that's what I want. I want to go to test me test. I want to go into build, and there's my files. Okay. And on the Raspberry Pi, Pico, plug that in with boot cell, selected. Wait for it to come up. There it is. And then go ahead and move my testbtest.uf2 over there. And if everything went according to plan, I should have a blinking LED if I remember to do things correctly, which I may not have. So right now, nothing's blinking. I know it's receiving power, but nothing's blinking. I was missing a few lines. Let's see if this helps. And again, this is all incantation from over here. I'm not going to worry about the printf. And I'm not worried about this because that doesn't, if CFG enabled, and we don't have that. All right, so I may need to do this. Why would we need to start all this up in order to get the LED blinking? I do not. Well, no, board init's necessary because otherwise it's not going to be able to do all this stuff. So that would make a lot of sense. Let's compile it and see if it compiles. Was it not happy? Undefined reference to TOH HID report refuse callback. Okay, so it wants TOH HID report receive callback. So let's put some stubs in here. Now, I've read the USB spec before, so I kind of understand what's going on here. That's the address of the device. That's the device incident information. That's the report itself. And that's going to be the length of the report. So I wonder why this isn't doing what it's supposed to be doing. Now I can go ahead and copy and paste everything over from the other side and it will work just fine, I'm sure, because I had this working before. Yeah, that should be everything that I need from the example file. Let's see if it compiles. And now it's happy. And I don't understand why it's happy, and it wasn't happy before. So now that it's happy, let's see if we can't, let's see if we can't load this up and see what happens with it. All right. All right, that goes over. That's expected. We'll close that, and let's see what's happening actually over here. And I now have a blinking LED. All right, so there was some boot stuff that needed to be done. All right, what's the minimal? What can I get away with not having there? So let me cut back to this. All right, so we've got the process KBD report. All we're doing with that is handling the actual keyboard report, handling the keyboard report itself. I want to see what happens and it didn't even complain about, oh, probably because it was already defined somewhere else. Okay. So if I get rid of these, am I going to, it's not complaining. All right. So what that tells me is those callbacks, those incantational callbacks, they're already declared somewhere. All right. You compile. You do compile. Do you make an LED blink? You make an LED blink. Unplugging that keyboard. Okay, it saw the end mount. Good. And it saw the mount, it saw the keyboard. Lovely. That's good. All right, so now we're seeing this. This is a good thing. What I want to do is I want to get the keyboard report. Okay, I see what's going on. There can be up to 6 key codes in a standard standard report, and this is, of course, assuming that we don't have an N key rollover USB keyboard. This is just a bog standard, non-gaming specific keyboard where you don't need NKRO. Okay. Only of the currently pressed keys. So the question is, does it send a report when we have release keys as well? And that's going to be the trick. That I don't know. I think it does, but I'm not sure. Part of today's experiment. Now, will this compile? It compiled. Will it start the LED blinking? And it does. The LED is blinking. I have a device. So let's see if it actually... Nice. Okay, so I got a key press and a key release. Key press, key press, key press, key release. Key press, key release. Oh, okay. So this I'm hitting the control key and it's not giving me anything here. Let's about Alt key. Alt key does not give me a Alt key does not give me anything. Alt. Yep, so I've got to look at the modifiers to see what's going on with that. And watch my wonderful use of the ternary. It's only giving me the press keys. It's not giving me anything else. So let's see what I did wrong here. Oh, no. I did it right. Okay, I see what happened. Because I don't have any modifiers down. Now I'm getting that. So if I do all this, and then, okay, that's because it doesn't like any more than 6 at a time. Yeah. Okay. So I'm getting scan codes. Let me check and make sure that it's correct. I'm hitting control. Yep. Gonna control. Shift is good. Win is good. Alt is good. Other alt is good. Other shift is good. Other control is good. And other Windows and one key is good. Lovely. All right. Marvelous. We're receiving the scan codes, which means that here later I can go ahead and roll that into a scan code translation, so that I can get that into matrix codes for the CoCo, and then the CoCo can then pull for those matrix codes. for the next thing, I am going to look at isolating the UART from the inputs. Now, that's not a difficult thing to do. It just requires using what's called an opto isolator. There are other isolators available, but ultimately the Pico is going to be powered by the CoCo. This is going to be powered by the CoCo. In my debugging and testing, I'm going to want to use the UART to talk to my PC. I don't want the PC or the CoCo trying to blow each other up by sharing a voltage and having a ground differential. So instead, we'll just go ahead and use this little bad boy right here, which is, if I can manage to find it, give me a moment here, the 6N137. Now, this is a discontinued part, but they're still relative. They're still pretty widely available, and they've got pretty good response times. I've heard that they'll do pretty well as far as going up to 115 kilobaud, which is about what we're looking for. And looking through the data sheet, let's see what we've got as far as switching characteristics. Propagation delay, time to output high level is average at 45 nanoseconds. That's not bad. Propagation design output, average of 45 nanoseconds. That's not bad. And worst case scenario is 75 nanoseconds. Looks like it should be fine. So back of the napkin math, let's see what the baud rate is roughly in hertz. All right. So if we've got 115,000 kilobaud, or 115,200 baud, and then we 1 over x that. Oops. How do I do that? Oh, in this one. There we go. Okay, 1 over x that. 8.6, 10 to the negative 6. That's a transition every, let's see, that's 10 to the negative 6, which is going to be microseconds. Okay, so that's a transition every 8.6 microseconds. Microseconds? Yes. Microseconds. And so 1 down from microseconds is going to be nanoseconds. So with that being 75 nanoseconds, maybe 100 nanoseconds, the worst case scenario, this should be perfectly fine. Output rise time is in the order of 50 nanoseconds, or 50 nanoseconds, and output, let's see, what are we looking at? Output, that looks like it's trying to be output fall time, actually, is on the order of 12 nanoseconds. So we should be well within spec. That shouldn't be an issue. Yeah, remember when I was griping about not having a chip puller? Guess what I found in my EEPROM programmer box? All right. So let's see. All I'm worried about is the TX side. All I'm seeing is the RX light illuminated. Like it's getting a constant +5. So that's not right by any stretch. Okay, I'm getting garbage. Good. That's good to know. All right, lovely. So that means that I do need to invert the signal. So if I go back over here, after all of that, if I go back over here, and if I say, GPIO set out over, let's see what if it recognizes it. UART GPIO. So the GPIO number should be 0. And the value is GPIO override invoked. All right. So if that's happening, if that does what it's supposed to do, what I should see is when I tie that in, everything should be fine. So let's compile it. It's happy. All right. Pull that. Gonna pull, that can live there. I'm fine with that. No, that can't live there forever. That needs to be removed. Pull this. Bring it over here. Let's go ahead and see what happens. Or just plug it in directly. All right. Now I'm starting to get garbage. Good. What do I do with my output? I think, is that my output? Yeah, that's my output. So this goes over here. That goes over here. And I need a 330 ohm resistor for current limiting between pin 3 and ground. Now, the LED inside that thing might actually light up. Let's see what happens. And we have isolation. Nice. Okay. That took entirely too long. That took annoyingly long going and diving into the SDK to try and find something that's annoyingly simple because I already knew which pen it was using and I was trying to go through and say, oh, which pen is it? Tell me what doesn't. This SDK is just so convoluted. It's like, oh my goodness. All right, so now I got to clean up my mess. So now that we reliably have the keyboard talking to the Pico and the Pico handling the keyboard and sending out the keystrokes and processing those, the next trick is going to be getting that keyboard matrix information into the CoCo. Looking at other projects, the way that we do this is generally by using what's called an analog switch. And the analog switch is just basically nothing more than a matrix of switches that is controlled by the GPIOs on the Pico. Oops, there we go. That's what I was looking for. All right, so if we look at this datasheet real quick, this is the MT8808. Fun fact, the DIP version of this is no longer in production, it appears, but the PLCC version is. And it's got a bigger brother that has a 16x8 array of switches that's actually more obtainable and cheaper. It just depends on where you look for it. But you can still find the 28-pin DIP sourced through AliExpress relatively inexpensively. And it has, if I find the block diagram here, where's the block diagram? Oops, that's not what I wanted to look at just yet. There we go. It has an 8x8 switch array that is handled by the X and Y axes that is going, these bits right here, a strobe bit to tell it that it's going to actually put the data in there, a data bit to say whether to open or close the switch, and a reset bit or a reset signal to reset the entire thing so that all the switches are open. At least I believe that's what reset does. Let me make sure. So there are our pen descriptions. The strobe input, which enables functions selected by address and data. Yep, got it. Address must be stable, blah, blah, blah. Data, a logic high input will turn on the selected switch. Logic low will turn it off. Lovely. And this is used to turn off all switches, and it's an active high. What this means is that I've got 9 signals that I need to take out of the Pico and put into this little bad boy right here. And this is our MT8808. Let's see, and that is, yep, there we go. And just for comparison's sake, I've got its bigger brother right over here, the 8816. And you can see, I mean, we got a, what is this, 40 pen dip, something like that? Yep, it's a 40 pen dip versus the 28 pen dip over here. And let's see, 28 plus 8 is going to be 36, so there's an extra 4 pins on this one. I'll bet you there's some that are not connected, but not really sure. Not looking at the data sheet for that, but this is the bigger brother. In any case, we'll put this away and save it for later. So one of the problems we face with interfacing this with the Pico is the Pico only spits out 3.3 volts, and this is a 4.5 volt part. It will not respond to a 3.3 volt signal, so we're going to need to do a level shifter. Now we're already using GPIOs 0 and 1, pins 1 and 2, for our UART, for talking back to the PC that we're talking about the PC that we're using for diagnosis. Well, all right, so that means that I need, if I'm going to do this, I need the strobe data reset. These X and Y pins, those are all the output pins. And so what I do need are AX 0 through 2 and AY 0 through 2. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 bits, which is most easily, well, most conveniently as far as I'm concerned, GP 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, this will give me this will give me pin 4 through 7, pin 9 through 12, and pin 14 that I can then map to these outputs. So there's my map that I'll use for later. Great. But before I even start wiring anything up, I want to make sure that I can actually use these GPIOs, because again, I'm dealing with that wonderful opacity of the Pi Pico SDK. There does exist something vaguely resembling documentation, but it doesn't really give me much in how things work and how things are put together. Here's what I'm assuming. I am assuming that this mask gives me access to GPIOs 0 through 28 in bit order, according to their NIT legends over here. So, like, if I send in a mask of, let's say 0x08, for instance, that will give me GP3. 1, 2, 4, 8, 10, 20, 40, 80, etc., etc. And then coming over here all the way to GP28. At least that's what I think is happening. Does let me look at things in binary is this bad boy right here. It'll come in useful. Setting up nanosecond delays requires inline assembly, and how inline assembly is going to work, I'm not entirely sure. Okay, we're using C, so I'm going to have to use that ASM keyword right there, and I'm using GCC, so just your mileage may vary. If you're not using GCC for inline assembly, you may have to do something different. Nanosecond level delays are not something that's part of the Pico SDK, so we're going to have to work out, using inline assembly, how many knops to put in there. Assuming that a knop only takes one cycle, which it looks like that's going to be the case, if we have 125 megahertz, which is 125 in our exponent 6, all right, how many nanoseconds is that? So remember, a nanosecond is 1 times 10 to the negative 9th, so if I do a 1 over x of this one, I come up with 8 nanoseconds per cycle. So with each nanosecond each cycle being 8 nanoseconds, I want to go ahead and review what's going on with the timing on, let's go ahead and look at the timing on the MT8808. Looking at this timing, everything seems to run in like multiples of 10 nanoseconds for the most part to make everything work. Where are my timings? I looked at this earlier. Here we go. So like hold setup time data to strobe 10 nanoseconds, hold time 10 nanoseconds, 10 nanoseconds, 10 nanoseconds. That's the min typical max. Max doesn't really matter until we get to where we're looking at the outputs based on the inputs. There is no real maximum for how long we can hold these values, but it says a minimum is like multiples of 10 nanoseconds. Reset pulse width's got to be 40. Strobe pulse width's got to be 20. Hold time address to strobe's got to be 10. Setup time address to strobe's got to be 10. And if we look at our timing diagram here, there's our 20 nanosecond pulse width. We've got 10 nanoseconds on either side, here and here. We've got 10 nanoseconds that we've got to put up here before we end the pulse. Realistically, what I can do, since the data latches on the falling edge, not the rising edge, I can go ahead and set up the data right here with the address, hold all that, and I've just got to make sure that data hold is held as well, and that's going to be a 10 nanosecond time as well. Hold data 10 TDH. That's saying it's 10 nanoseconds. So this should all be fine. Now I've got an 8 nanosecond cycle, so that means that I can do multiples of 2 cycles. If I do 16 nanoseconds, that can give me a delay unit. So let's see if that compiles. It's happy. Oh, with minus save temps. Okay. Oh, it's in CMake files. Okay. I wonder if there's an ARM. Let's see. I need to look at my extensions. Let's install that. That's a lot of strange stuff going on. I have no idea what I'm looking at here. We got a knob. Okay. I don't know why it's acting like it's commented. Oh, because knobs are just going to be green, I guess. Okay. So they're in there. Lovely. It's in there. Good. So that means that I know that's in there for the assembly, which means that I know that I can make that pause happen. And I mean, that means that I can go ahead and make this a define in here. should work with this bidirectional level shifter. Let's see what happens. It appears to be working just absolutely fabulously. Yep, there's my 3-volt signal. And there's my 5-volt signal. Beautiful. All right, so that's working, and we know that the level shifters are going to work. We know that knobs are going into the code, so I know I've got good delays. I know I've got good other stuff like that. And that's all I'm going to do for right now. We're going to take a little bit of a break. Well, I went and spent some time off camera to try and figure out what the heck was going on, because I figured that part of my problem was simply that the wires weren't doing what they were supposed to be doing because I'm using El Cheapo breadboards. Note to self, get better breadboards. Okay, so I went and wrote some new testing software or testing firmware for the Pico. Let me get that pulled up. So here I went ahead and split things out into different header files, made sure that I had all my strobe information, everything broken out so I knew exactly what I was doing. Simply made a blinking task in the keyboard report. So, and walked through every single piece to make sure that I understood what I was doing and why I was doing it, including marking out the incantations. So reversing the UART 0TX sense, because we knew that needed to be done. It's the startup incantation for everything. Initializing the GPIOs, making sure those are good. One thing that I, making sure that the maskings were doing what it's supposed to be doing, which we already know it is. Mount the hid device, start looking for key presses. That much we already knew was working. And I honestly don't know what the heck this is here for. Start receiving the reports, and then do the report, then handle the report callback as well as the keyboard report. So what I'm doing with the keyboard report here is I'm just using a series of keystrokes to determine which ones get turned on. And you see that I do have a sign of life. I've also hooked up an external power supply rather than playing off the serial port. So hopefully this won't crash as often. Yep, there we go. Initializing GPIOs and waiting for reports. Orientation's correct. Plug that in. HID device attached. Now, if I'm looking down here, what I should see, if I did this correctly, it's going to, let's see, I should be able to hit the reset. It's receiving the reset, and yes, I have. It's hard to see the blue LED glow. Yeah, you can see it glowing. Okay, you can see it turn on and off. Great. Reset turns on. Great. Let's see. The other one was strobe. And you can see that strobe turns on and off just fine. And then we've also got our, what else was there? Oh yeah, the data. And data turns on and off just fine. And so if I want to do like row number 7, row 7 turns on just fine. And escape goes ahead and clears that out. Let's see, let's try row 7 again. And let's try column 2. There we go. And if I go with a strobe, and then I clear that, data, strobe. Okay, now, if that did what it was supposed to do, we should see this coming over here. Now you see this bunch of LEDs over here. I just simply have not hooked that up to show anything yet. So let me, just in case this actually is working, which it should be because I already tested it, hit the reset. So I go with, let's see, delete gives me a reset. We'll toggle that. So if I come back over here, and go to, let's run my reset set toggle again. We'll hit column 3, and let's hit row 4. And if I strobe that, and then hit data, yep, there we go. Oh, right. Because I have to clear that, I have to stop the strobe because it's transparent at that point. It latches on the falling edge. So this is working. Now, with that said, I should, you know, on Lark, thinking that I probably didn't, thinking that it might just work with the timings that I had, I went ahead and loaded up the firmware that we had been working on prior to me getting frustrated and taking a break. And when I tried that, oh, that's because I'm, okay. When I tried that one, I think it actually did try to work. So, I've got that connected to column 3. So, I should see something light up on these when I hit the Alt key. And I do. I see row 6, and where I'm numbering 0 through 6. Okay, so that's 0, 1, 2, 3. Okay, so row 6. So the semicolon plus should be my row 5. And that is correct. 3 sharp should be, yep, there we go. And I go to the up arrow. And it looks like everything is working perfectly fine. S, K, C. And if I do something like a C and hold down the up arrow, that comes on. How about the Alt key? That comes on. And let's try this. This should have an N key. This should have a rollover of 6. It only gives me 6 keys at a time, but it registers all 6 of them. Ain't that a peach? So we do have at least 6 key rollover with this. All right, lovely. So now that's working. Now the next trick is going to be getting this interface with the CoCo itself. And I'm gonna try this. I tried it when I was testing all this, and I think and it didn't go well. I think I know why it didn't go well. So. That. Now I'm not going to pull power from the CoCo to run the switches. Instead, I'm going to go ahead and give it its own power. Let me make sure. Yep. Okay. We're getting signals here. Good. And now. Got that hooked up. Bring on the CoCo. CoCo's waking alive. You can't see because I've got that in the way. Let's see what we get. We're getting something. I wonder if maybe I just don't have some bad column things in there. I'm going to try this again, but with a different set of cabling. A different set of cabling. All right, that's hooked up. That's hooked up. Get the serial terminal hooked up so we can verify operation. And get good. And power. Good. All right. Make sure that I'm sending. Yep, I am. And now let's see what we've got. It was the cable. Lovely. All right. I had that sitting over the top, so you didn't really see all of it. But let me bring it on down here, and I'll go say, it's working. It's working, and it's working with a happy. Okay, great. All right, done. Now, one other thing I do want to test. Now, according to the schematic, I should be able to get a ground off of TP4 and a I can also get a ground off of TP3. And I can get a +5. Off of TP12. Now TP12 sitting over in here, and last time I tried this, it didn't like it very much. So let's see if I can hook TP4 here. Let's see if I can hook TP. It is TP12. Yes, TIS.12. There we go. And let's see if it likes it when I turn it on. It's perfectly happy. It's absolutely perfectly happy. Oh, that makes me so happy. That makes me so happy. Okay, so we can get power off of that. We just got to find the little clippy points to get it. All right, awesome. I have a working USB keyboard in Pico. Nice. I'm so happy it worked. Okay, so I'm going to stop here with this video because there's more that I want to do with this. For instance, I want to put together a shell that will replace the keyboard itself so I can stick it in there. And within that shell, I want to mount a PC board that will have the Pico and the adapters and everything like that. I want to make it so that we've got a little bit of perhaps a display on the keyboard itself that tells you what you're doing. And I also want to add some mapping capabilities in there. Now, some of this stuff is stuff that can be done off camera, but I've got a sneaking suspicion that I'm going to treat it like the fourth ROM, in that as this progresses, you'll be following right along. So next in this project series will be to get the PC board made and to get that fabricated, get that put together, get some more MT 8808s. Hopefully they'll work. And yeah, it should be great. I look forward to having something that I can just put in there and it looks real pretty, and it's just got some places that you can plug in a USB keyboard and it'll be wonderful. I think it'll be great. You know? So stay tuned for the next installment of this project, or the next installment of the fourth project, or something completely different. Whatever it is we wind up doing, make sure to like, share, and subscribe so that you don't miss the next little bout of insanity right here on the Break Key.